Hi everyone, I am Shargay Sabinanyas from BSN2Q. How do you fairly divide political power when the numbers don't split evenly? Imagine you have 100 seats to distribute among states or parties based on the population, but the math doesn't work out perfectly. That's where the Jefferson Method comes in. Developed by Thomas Jefferson, this system was one of the first attempts to solve the problem of fair representation. But is it truly fair? And how does it compare to other methods? To break it all down, let me hand it to my co-group mates to walk you through exactly how the Jefferson Method works.
Good morning, everyone. I'm Simon Nolo Vergara from 2Q. So, we will be talking about the Jefferson Method. So, first, what is Jefferson Method? Jefferson Method is a voting system designed and allocate seats in the representative body, most commonly used in the context of apportionment election. So, kisa may nag-develop ani nga method. It was Thomas Jefferson, the third president of the United States. Siya ang nag-create ani nga method. So, unsa may description ani nga method? So, the Jefferson method involves dividing the total population by the number of seats to determine the standard divisor. So, each state's population and then divided sa divisor to get a quota, which is rounded down to the nearest whole number. If the total seats, a number of seats allocated is less than required or less than sa quota, then the divisor is adjusted paubos or downward. And then, ang process is, ang kanina nga process kay magsige ni siya balik-balik, repeated, until ang correct nga number of seats kay ma-meet or ma-allocated. So,
hi everyone, hi to you sir. I am Jana Nina Birias from BSN2Q, and now we're gonna tackle about the Jefferson's method. And in my part, I'm going to talk about definition of terms. So what is the Jefferson's method, right? So it is a way to allocate seats in a legislature by dividing populations by a modified divisor and bounding down. And it is also known as the Donth method or the greatest divisors method. So how does it work? How does the Jefferson's method work? So we have the 4 steps of how does it work. So first is assign the lower quota to each state. So each state is initially assigned the lower quota, which is the whole number part of its population divided by a chosen divider. Next step is if the total number of seats is too large, increase the divisor. So if large ang imuhang population, or maybe the number of the seats, increase the divisor. And the next step is if the total number of seats is too small, decrease the divisor. So sa first, katong seats, if the seat is too large, you should increase the divisor, right? And for the next step, the third step is if the seat is too small, you should decrease the divisor. And the last step is repeat until the correct number of seats is assigned. So you should repeat all the steps, the 1, 2, and 3 steps until you get the correct number of the seats. So that is the method, or that is the rule of the Jefferson's method. And we're gonna tackle about also the history of Jefferson and why did he make it, or why does this become a method for us. So Thomas Jefferson, the future president of the United States, developed the method in 1792. And it was used to allocate seats in the House of Representatives until 1842. And it is still used in some countries today like Slovenia, Japan, the Netherlands, and Israel. So, yeah, mao din na ang rasonan ng gihimo ni Thomas Jefferson. And also, we have the features about the method. So, Jefferson method favors larger states or parties, and it's a highest average method, which means it reduces political fragmentation for smaller electoral districts. So, what is favors larger states or parties? So, since it rounds down when assigning seats, larger states or political parties benefit more. And for the higher or the highest average method, it distributes seats based on the highest average rather than strict quotas, which helps prevent excessive political fragmentation, and especially in smaller electoral districts, just like what I said earlier. And it makes it particularly useful in proportional representation system. So, muna na siya ang definition of terms for the Jefferson's method, and I hope you understand and naligamay nga ka ng idea what is Jefferson's method. And that's all. Bye!
Hi everyone, I am Nicole Kit Pardilio. I'm from BSN 2Q, and today I'll discuss the steps to implement Jefferson's method, a way to fairly distribute sets. The steps to implement Jefferson's method is first to calculate the standard divisor. It is by simply divide the total population by the total number of sets. Second is to determine quotas. Then, divide each state's population by the divisor to get its share. Third is to round down quotas. Just round each quota down to the nearest whole number. Fourth is to adjust the divisor. If sets are too few, reduce the divisor and try it again. Fifth is to repeat until set requirement is met. Keep adjusting until all sets are assigned properly. And that's how Jefferson's method works.
Hello everyone, my name is Giselle Diesel Victoria from BSN 2Q. For the sample problems, here it is for us to understand more what's our topic all about. For the sample problems, step 1 is the standard divisor. The standard divisor is used to determine how many people on average should be represented by one seat. This is calculated by dividing the total population by the total number of seats.
Hello there viewers, I am Eric John Uba and I'm from BSN 2Q. Now for the solution, again, so we have total population of 1 million and the total seats of 10. So the standard divisor is 1 million divided by 10, so it equals to 100,000. So this means that each seat represents 100,000 people.
And now for the step 2 is the initial quotas. For the initial quotas, now that we have the standard divisor, we calculate the initial quotas for each state. This represents how many seats each state should ideally get based on its population. For each state, we divide the state population by the state's divisor.
Now for the step 2, for each state, we divide the state's population by the standard divisors for 100,000 people. Now for the state A, 500,000 over 100 or divided by 100,000 is equals to 5 seats. And then state B is 300,000 over or divided by 100,000 seat is equals to 3 seats. And state C, 200,000 divided by 100,000 is equivalent to 2 seats. Now for the total seats, now we add up all the initial quotas to find the total numbers of seats allocated. So 5 plus 3 plus 2 is equals to 10 seats. This matches the required total number of 10 seats, so no further adjustment for our sample problem.
Good day everyone, this is Shawnee Magdalero from BSN2Q. This allocation is perfectly balanced. So in this case, State A gets 5 seats, while State B gets 3 seats. And lastly, State C only gets 2 seats. So the total number of seats is exactly 10, which is what is needed. So therefore, no rounding or further adjustments are needed. Thank you.
A pleasant day to all. I am Manuel Luis Arañas from BSN 2Q, and I'll be discussing the conclusion or generalization of this topic. This topic is all about Jefferson's method. So Jefferson's method is a divisor method. It is used to allocate seats based on population. And it is important to remember that it is the quotient that determines the number of seats. So a key difference of Jefferson's method compared to other methods is that it uses a lower divisor. This will result in different states having fewer seats, especially when rounding down is applied to the quotas. So while Jefferson's method is used to prevent overrepresentation, it does have a downside, which is there could be an imbalance in the allocation of seats. This imbalance happens especially when we're rounding down, and then it leads to a discrepancy in the total number of seats. But despite all of these, Jefferson's method has been historically significant in providing a way to allocate seats in a way that balances representation across states with different population sizes. So in conclusion, Jefferson's method is a very practical tool, but it is not without its limitations, especially regarding fairness when rounding quotas. So this has led to other methods being used for accurate apportionment. So this is all for our topic, everybody. I am Manuel Luis Arenas III again from BSN 2Q, and thank you for listening.